Build Show Live 2024 conference classes are brought to you by Builders FirstSource, Huber Engineered Woods, Pella, and Sashco. This session is sponsored by Polygaurd.
Hey everyone, I'm Zach Detmore and I'm here at the first Build Show Live. And none of this would be possible without our amazing sponsors and partners in this event. If you're unable to make it to this one, we are going to have another one next year in Dallas in 2025, so hope to see you there. But I want to take a moment to call out Sashco. If you're unfamiliar with them, they've been doing this for about 85 years, specifically making super high quality sealants and caulks. The lovely thing about them is they're focused on the end user. They have the customer at top of mind, and that's why I like using their products, because they're easy to work with and they're durable. I'm always concerned about warranties and callbacks, and having a failed sealant is really something that can be expensive because it usually involves repainting or disassembling things, and I don't want that. I'll give you an example to sort of help you understand the difference. So if you think of a fiberglass tub, for example, the fiberglass tub is here, and then you have the tile coming on top of it. And in New Jersey, where I build, for example, if we frame something in the dead of winter, the humidity is very low, so that framing member is sort of compressed as small as it will be. And then come, the middle of July, when it's super humid, it expands, and what happens is the gap between the tub and the tile can open up. And also when you're getting into a tub or you're loading a tub with water, sometimes the fiberglass will come down, maybe you don't have a perfect bed of mortar below your fiberglass tub, and you get movement. The point is, houses move. And if you have a sealant like this, which is sort of probably very commonly used, you'll notice it is stretchy, right? But the thing is, it takes a tremendous amount of force for me to keep this tension. It wants to return back to its previous state. Versus if I use some of the Sashco products, this is actually very stretchy, much more stretchy, but the cool thing is it sort of relaxes in this stretched state. So it's much more likely that this is going to remain bonded to the tile and to the tub and remain waterproof through sort of the life cycle of the house. And it's very common for me to have to come in and remove poorly installed sealant because of this exact issue. And that's really why I use the Sashco product line. They have a product line for everything from roofs to windows, and they make a product for each specific application. So if you're unfamiliar with their products, actually click the link in the bio and they'll send you a sampling of any one of their products for you to try out. I highly recommend it. See you at the next Build Show Live.
So just to get it out of the way right off the bat, want to acknowledge our classroom underwriters, Builders FirstSource, Huber Engineered Woods, Pella, and Sashco. Part of the building science track that we have is Polygaurd, and then Vapor ICS is actually underwriting this particular course, and they do vapor barriers. I have some samples, we can go over that a little bit later. All right, so we are here, what lies beneath unvented crawl spaces. But to begin, it's kind of nice to know the demographics in the audience, I think. So if you guys are comfortable with it, who here is in kind of the design, project development, engineering side? Okay, so we have a couple. And then how many of us would identify as a builder? Not necessarily boots on the ground, but at least managing. You could be a superintendent, something along those lines. And then how many people are kind of owner-operators? They build the houses, but they also get in the trenches and do the actual work. So I think that's actually a really nice cross-section. That was one of those things that you just don't know until you get here. Now, who here is part of Santa Fe dehumidifiers and teaches multi-hour-long courses on Crawlspaces? We've got Nikki Kruger with us. So she can back-check anything I say, which is nice. She is truly the expert here. But hopefully in an hour, we'll be able to learn some things together. We can pass on some lessons learned. I fall into the second-generation builder category. So my dad started the company back in 1978. I came along 2 years later, and thankfully the company is still an ongoing concern. and I run the business now. My brother, you might know Tim at Awesome Framers. People wonder if you do know him. He is my older brother, and he's done a lot more of the hands-on operator type things than me, even though I've done plenty through the years. Anybody who's run a business knows there comes a point where you can't do everything. So sometimes I'm out there in the field, but for the most part, I manage the process. I get to dig into the code, work with architects and engineers, serving something as a design coordinator. And as we go through, you'll see how important that is, because unvented crawl spaces are not that well understood. They may be done, but do we understand the principles behind why we're doing these different things? Kind of the general outline of this talk will be what a crawl space actually is. We're going to talk about the structure behind it. We're going to talk about, should I even build a crawl space? What are some of the factors? So that goes into kind of the design. You want to be thinking about that in advance. Not just take this as a prescription and I'm going to go ahead and go do that thing. Learn the principles, understand what you're doing, and then make the decisions with knowledge that work in your application. And then we'll do the building science. Well, then we'll talk about to vent or not to vent. And then we'll also go through the building science recipe. So that's going to be kind of like, if you're a baker and you go into Good Housekeeping, that's an old magazine my mom used to get, so I don't know if it's still in print. But if you get Good Housekeeping and they have, here's your list of ingredients, it's not always just the ingredients, but they'll actually have kind of a paragraph of preheat the oven to this and go through all of the steps of the recipe in order to get the cookies or the cake or whatever you're doing. So it's kind of the same thing. Not just here's the list, anybody can produce a list, but then how do you actually execute that in the field? Or if you're overseeing people, if you know how to demonstrate it, if they don't have experience with it, it goes a long way, and it shows that you're willing to get your hands dirty. So in this particular image, this is technically a deck, but you can get the idea of it being a crawl space, because this is one of those words in the English language that's like German. The word describes what the thing is. It's a space that you can crawl in. But it is more than just a place to crawl. So how would you define, if it's okay to have a little audience interaction, what would you say a crawl space is? How would you define it? Any brave souls out there? The best room in the house. A space you have to. Yeah. Mechanical storage. Yeah, a lot of different characteristics. From a code perspective, it's an uninhabitable location. So a basement, if you've got your paths of egress and things of that nature, you're going to be able to inhabit the space, but by definition, we don't live in a crawl space. So just kind of keep that in mind. We're not trying to design something that has this type of illumination, this type of air exchange for our lungs. It's not a house. It's kind of a buffer space. And depending on how we construct it, it will either be more like the house, but not identical, or it will be more like the outside atmosphere, but not identical. Even if you do an unvented crawl space, it's not part of the house.
I would say inhabitable by humans, maybe.
Yes, thank you. Or if your kids are really acting up. So if we look at our picture here, this is not our concrete work. We typically do our own structural concrete, so with some of these pictures, I'm not going to take credit for the concrete work itself, but we're just going to go through some of the anatomy. So the gray part is your concrete. So what are you doing with your concrete there? You're trying to pick up the vertical load. So again, we're going to talk about the structure first. So as you're constructing your house, everything you put on that house is going to have a weight to it. The very lightest part of the house is going to be the ridge. And everything you subsequently put on stacks in weight all the way until it has to get to the foundation, whatever it is that you're going to distribute that load. Your foundation concrete is going to be your strongest part of the structure, likely even stronger than the soil that's underneath it. You might have heard the term weak soils. So depending on where we're building, the soils can be weak. And what I want to convey is we want to think in terms holistically of everything that's involved. So that's why we're talking about this. Embedded in the concrete is going to be rebar or reinforcing bar. So the concrete itself is typically not strong in tension. It's very good in compression. So that's why you have rebar put in there. And then you have vertical rebar, and I would say that that's for two reasons at least. If you have that rebar in your foundation stem wall, you have to hold it up somewhere for when you're casting your concrete. But it's also for your lateral analysis. So if you're in a high seismic design category, you might have more vertical rebar. And again, we're just trying to understand more fundamentally what a crawl space actually is. There's different foundation systems, and we'll talk about that later. So that's concrete. This is cast in place, which is typically speaking going to allow for less vapor transfer through it because it's a more dense material. Different parts of the country, depending on where you're from, you might be building with concrete masonry block. And if you got to see Matt's opening talk, water is the big deal for buildings. So if you have concrete masonry block, even if you have some of it grouted, generally speaking, you'll be able to transfer more moisture through water diffusion through the concrete. Why does that matter? You can see what we have on top here. We've got mud sill. It's made of wood, even though it's treated. You've got I-joists, which are also made of wood. In this case, there's a structural rim joist that we have on there, an engineered wood product. If we don't take care of the moisture in our crawl space, over time, it could lead to problems. That's simply put. So we want to be thinking about these different methods of moisture migration for what can come into a crawl space. Can you think of what are some of the places that moisture, liquid water, can get into a crawl space? What are some things that we might have to address when it comes to liquid water, do you think? Water table? Yep. Any other place?
There could be a leak.
Yeah, the heavens. I'm from Washington State. So you're going to want to address your liquid water first. We're going to get into some of the membranes and things, but a vapor barrier is for vapor diffusion. It is not a waterproofing like a liner that you would put in your shower that is a waterproofer. So the most important thing that you can do on your house, even though we're talking about foundations, is how are you going to take care of the water that's coming in from the sky and hitting the roof? Because ask me how I know. We have had so many problems in our crawl spaces. My dad, bless his heart, both of us have cost accounting. That's what we do. And the higher and the more concrete you put in, the more money you're going to spend. But it's safer the higher you can get your concrete and stay away from the water table and slope the outside of your house. If you can eliminate the liquid water from getting in, most of the rest of this will take care of itself. It's that critical. So not only when it hits the roof, but then it hits your gutters, it hits your downspouts. Do you have a tight-lined perimeter? So where you're conveying that water to some other location, maybe you have on-site water, stormwater management, or you have a ditch or something, get rid of the water. So if you take like just 1 point from this talk, make sure you know where that water is going to end up. Of course, this is a floor system. Some other things that you might be able to see. This one has anchor bolts with nuts and a plate underneath it. So that's how you're going to be holding down or technically anchoring the structure itself to the foundation, and that'll come into play later. So in that case, these J-bolts were cast into the concrete. They were sticking up from that stem wall. So if we started from the bottom, from the ground, typically you'll excavate out, you'll have your footing, your stem wall, and now we have the structure, and it has to be connected some way to the foundation. In this case, it was anchor bolts. So here's just a closer view of that. This is inside that joist bay. In this case, we have the joist sitting on top of the stem wall. Another thing you can do is take your floor system and hang it down within the stem wall. Where we're at in Washington State, we tend not to have a whole lot of flat sites unless you're a big builder and they've done site development where you've got the cutting and filling. A lot of times our sites are one-offs and we've got a lot of hills where we live. So we have to try to contour the foundation into what's existing on the ground. And so a lot of times we'll have the back of the house have a taller stem wall, and then we might hang our joists down inside the foundation, and then it can actually come out to the front and sit on top like this. So just some, I guess, design to think about in there. Again, we didn't do this concrete, but we're going to use it for the purposes of our illustration. So you're tracing some of these loads down. In this case, we have free spanning joists. It's actually a pretty decent crawl space to crawl around in. This is an intermediate wall that supports the center, and sometimes you have to do that to pick up some of the shear loads. We're in a seismic design category D2, so we have different requirements than maybe where you have to build. Or if you're in Florida, Miami-Dade County, we were talking about vertical loads. That might be where your lateral loads are coming in. It's just like a sail. Imagine if somebody took a big fan on this face, the whole thing's going to want to fall over. But if you take a buttress behind it, now you're going to be able to stiffen that up. So that's kind of how lateral analysis works. I'm not an engineer, so I'm not practicing engineering. One of my best friends is a structural engineer, and he said I'm a closet engineer. So anyway, what they have here is a cutout so that we can get into both sides. And for some reason, they put ventilation ports in there, and I don't think it's doing anybody any good. But that's what they did anyways. I'm pretty sure all of the air is going to be able to communicate. You can see some dampness on the ground. You can see maybe there was something stored up above on the right-hand side because some of the soil is dry there. But we're not getting any liquid water in this crawl space. So that's important to know for when we do it later. This one has a tight-lined drainage system for the gutters and downspouts. You can also see a pony wall in the back and where the foundation stepped down. But it's a pretty big space. So one of the comments that was made earlier was for mechanical storage. If we can get our crawl space to behave in a non-extreme manner, it's free square footage. Like, that is a large volume of space that we can utilize. So the key is, how do we make it a place that we don't mind putting our mechanical systems in there? And that's what we'll talk about today. So that was an intermediate strip footing with wood-framed wall. This is the outside. Again, it's a deck, but you can see our concrete pier, and it's just carrying that vertical load straight to the earth. We have a connector at the bottom to the 4x4 post, to another connector to a beam, and then the floor system. So it's just, even though this isn't a crawl space, I wanted to include it so that you could see this is how a lot of other crawl spaces might look on the interior, and they're more difficult to detail when you do your vapor membranes down there. If at the design stage you're able to maybe source a TJI or some other engineered wood to get more free spans, it makes everybody's life easier. If you choose to put your ductwork in that area, it's easier to work around. You're not trying to route your ducts all over the place. I can't make my bed very well. My wife does an amazing job. Imagine me around all of these trying to get the folds properly around the post. It's just more difficult. So at the structural phase, if we're able to work on some of those things, eliminating piers, if you're doing a truss system and you're throwing all your loads to the outside, you make your crawl space easier. So for those who are self-performing, and if you have a say on the design, you could keep that in mind. All right, so why build a crawl space? We've talked a lot about what it is as compared to. So before I click on the next one, how many people here typically build on crawl spaces? And then how many on full basements? And then how many on slab on grade? So the majority. Why, if you build slab on grades, are you in this class? I am so glad to have you guys here. So we're going to talk about slab on grade, and you guys are the experts on that. In our area, it's pretty much always a vented crawl space is the standard in our area. We're climate zone 4C. for those who want to know. Quick side point, the number part, no, Joel, not you. The number part of climate zones refers to the temperature, heating degree days and cooling degree days. So if you're 7, it's going to be super cold, 1 is hot. The ABC refers to moisture. So humid, not as humid, and we have or dry, we have the privilege of being marine sea. So that just means we're really wet and miserable and we have seasonal depression. Joel?
Do you do any slab-on grade?
We do, but it's not your conventional slab-on grade. Usually when we do a slab-on grade, it's a hybrid of a walkout basement, and we usually use the foundation basement wall to restrain the earth. It's usually a restrained retaining wall, meaning that you're able to pick up some of the lateral loading with your floor diaphragm, instead of your conventional retaining wall where you bury a portion of your footing under the earth to keep it from overturning.
So is it the topography that's driving your decision for?
Exactly. Yeah, if your driveway is here and your lot slopes like this, we're going to carve out the hillside and slide in the house to restrain that earth. And so now you've got a level that you can walk out here. Typically we'll have a deck off the back, but on the front it will be at the natural grade. So we're not, Frank Lloyd Wright, build it to the site. Conversely, if your road is down here and it slopes from low to high, we'll carve it into the ground that way. But in that case, we end up doing that slab on grade, technically, but it's really part of it's a hybrid structure. But it becomes conditioned space, 100% conditioned. So there was an intermediate footing between the outside footings, and then an intermediate wall, and then the floor joist sat on top of that. So because of them being engineered I-joists, they were able to span that whole distance. It eliminated the piers. Does that make sense?
I'm visioning. I've never seen that like that.
Yeah. Thanks for asking a question. Okay, so SOG, slab on grade or slab on ground, we've kind of talked about that. Full basement. So if you have a piece of property, all things considered from a cost perspective, slab on grade is going to be your least expensive option. Imagine if you took all of the stem walls of a foundation crawl space and collapsed them. Maybe, because they're going to be thicker, 6 to 8 inches, depending on a variety of factors, maybe you're going to be a wash in terms of how much concrete you use. You might have an extra pump cost. Again, cost accountant here, but that's part of this discussion is you have to think in terms of the value, what you're getting. What you really eliminate is a floor system. So that whole floor diaphragm can come out of your cost budget when you do a slab on grade. A lot of factors, we won't get too deep into the weeds on that. A full basement can be nice, but I'm kind of in the business of, one, trying to see what my market around me is doing. If you're overbuilding too much and you're a spec builder, you just can't sell your houses. You have to have a good reason for doing it. In general, if you have full basements in your area, there's a reason for it. There was a few hands, you're probably from New England, or at least a colder area. That's my guess, because you have to get below your frost depth. So that's just a given. Unless you do a shallow frost-protected foundation, I'm not experienced in them, so for the purposes of this discussion anyway. A basement, when you dig into the ground, one of the very first things we talked about was the liquid water you have to deal with. There's a term, it's called capillary fringe. So I wish I would have started that band name back in. But capillary fringe, the water table will change seasonally. And what's going on when it comes to soil particles will change throughout the year, obviously. Summertime, it's going to be wetter or drier. As you get through the winter, the moisture content will be more. Very simple. The deeper you dig, the more chances are that you're going to have a water problem. We already talked about how to mitigate the sky. You just don't want to deal with a water problem. So in our area, there would be exposure to risk, is why we would prefer not to. But then also the cost of excavation is astronomical. And then you look at your actual site. Do I have a place to take my excavated earth and store it on site? And then is there a place, do I have to pay for trucking to take it out? There's all of those factors, and all we're doing is determining what kind of a foundation system that do I want. But the exposure to risk is a good thing to think about. All right, let me just see where I'm at here. Okay, some advantages, though, when it does come to a basement might be where you put your mechanicals. It might give you a little bit of extra space. Again, if you're going to make it habitable, think of things like if you put a bedroom, how do you escape if there's a fire or if somebody has to come in and do a rescue situation. Much of it comes down to cost and the way people build in your area. Now, I would kind of submit another element of this is comfort. So walking on concrete all day long, in my mind, it just doesn't feel as good as something with a little bit of resilience, something with a little bit of absorption of your foot striking, if you're doing it all day long. So to me, that's one of the benefits of a crawl space. I'm not here to try to sell people on it, but if you're kind of just thinking about it, wood is an amazing material. All things considered, it's renewable. You're going to have less carbon issues. But then you might have to think about your floor spans, how it's going to be comfortable, but ultimately we want it to be about how a homeowner is going to actually live in the building in order to feel comfortable. So we've talked about the structure. Why build a crawl space? Hopefully we've established and we decided, yes, this is something we want to do. Now the question, to vent or not to vent? That is the question. Shakespeare said that first, but then it got edited out. All right, I always start with the building code. In our area, Washington State, we have I think we're under the 2021 Washington State IRC with amendments. Learn the building code. You might not be comfortable with it. I'm going to expose you to a couple of things here that will hopefully make it a little bit less intimidating. The way I was raised, Dad only learned the building code for issues that he failed. That's it. Like, I don't know why we have to do this, but I know if the project wants to continue, this is what we're going to do because I know the inspector who's coming. And there's no criticism for that. It is what it is. In fact, he would intentionally not do everything to pass inspection the first time so that the inspector would find something wrong, mark it up, and feel okay leaving like he found something. Dad's philosophy was, don't make them look for something. Just give them something easy. I'm cut from a different cloth. I would rather pass inspection and keep moving forward. So this, I would highly recommend, and they've given me a free subscription, so just full disclosure, Upcodes is an amazing resource if you want to do code research. Sorry. So I'm just going to show you, this is how easy it can be. We're going to Chapter 4, Foundations, R408, Underfloor Space. This is kind of where you're going to be living when it comes to crawl spaces. Here's the section on ventilation. In our area, it is code required to have a 6 mil plastic, a vapor barrier on the crawl space floor. Your code may not require that. You may not have code enforcement in your area. There's a lot of the areas of the country that's just the reality. But I think the science is relatively sound here, and there was just a new addition put into the building code that instead of having to supply air to a crawl space, we'll just keep that going, or do an exhaust fan or things of that nature, we can now mitigate our humidity with a dehumidifier. Just checking my time here. So know what the code is, and let's just say that they haven't adopted that portion of the code in your area. Maybe they're under the 2018, 2015, Nikki knows this better than I do. She knows the history of this. There's a portion of Chapter 3 in the IRC that basically allows you to use alternate means, alternate methods. So if you can make a good code case to your code compliance officer, whoever it is, you may be able to use a dehumidifier instead of what was in the code previously. So I've just been through this situation, came up with our details and how we were going to be handling these different things. It went through without a hitch. The alternative is to build it the way you think it should be built and take a roll of the dice when the inspector gets on site. And that's not a risk I'm willing to take. I think you could get yourself into a world of hurt there. Sin now, repent later isn't always the best thing to do. Okay, so when you go in Chapter 4, you'll notice this highlighted section here, and a radon system shall be installed that meets the requirements of Appendix AF, Appendix F, radon of this code. So this was actually filmed by Upcode, or however they did a screen recorder, and it looks so much better than what I've done. So you can see they're just searching for radon control methods, and you can just watch that while I kind of talk through it. So where I live in Washington State, it's west of the Cascades. East of the Cascades is a more high radon location. Radon is basically a naturally occurring gas that is released from radioactive decay. What we don't want is to have that accumulate in our houses, just to keep it simple. If you have a vented crawl space, you're allowing that natural gas to go back out into the atmosphere. And all things being equal, the house is probably fine. That's why the building code allows it. I think there's 2 counties in Washington State where it's illegal to build an unvented crawl space. It's not because of moisture, it's because of radon, which can, I think it's lung cancer, is that right, Nikki? We're trying to build healthy homes. So we don't want to miss the forest for the trees. Build this place that's so energy efficient and we're saving money and then somebody gets sick. We've missed the point of what we're trying to accomplish here. So keep that in mind. You may have to mitigate for radon. You know the area where you build, if that's going to be a likely factor. In our area, even though we don't have radon in the geology, it's still code required that we mitigate for radon. So is it a glitch in the code? Maybe, but I'm not really going to use a whole lot of energy arguing it. Just get it done. What is kind of nice about it is you still have to test for radon if you do this, if you have to adhere to this section of the code. And then that'll let you know if you have to do something beyond passive ventilation. So let's see if this is... I might have missed one. But in any case, here's another way to get to that same code section. And I'll just let that play all the way through. Here you can see the map of Washington. There's counties that you can look up to see where is my county falling in with this. Now, I've heard anecdotally that you can have one house that's fine for radon, but just a little ways away, they test for it and it has a problem. So to me, it really is a case-by-case basis. I don't know exactly what the geology is under every site that I build. They have standard details in the code. You can start winnowing it down pretty quick with what foundation type of system you're going to be meeting. For the purposes of this discussion, of course, we're doing a crawl space. So that is another factor. We've talked about liquid water. We've got vapor diffusion, especially depending on the type of concrete you use in your water table. Another factor comes down to how much humidity is in the air. So we talked earlier about what kind of a climate zone we're in. Being down here in Texas in November and going outside and just feeling wet, I don't deal with that back home unless I'm working in the rain. Even when it's not raining down here. Imagine building in Louisiana or maybe parts of North Carolina more toward the coast. You may start to have an issue with your humidity if we start bringing in that really air-soaked atmosphere from outside into our crawl space. We talked earlier, we have all this volume. It seems logical and rational to use it for mechanical systems, but if you're using air conditioning and metal ductwork, in your crawl space and you start bringing in this wet air and it hits that surface over time, it can start to accumulate. You start getting condensation, and you can get some really nasty, moldy crawl spaces. So that's one of the chief things that we want to be factoring in, is to make sure that we don't get wet crawl spaces. Yes, much of our structural loading is handled by the foundation, but we just saw how much of the rest of it was wood. And those microbes just love to eat wood. If we give them the Goldilocks zone of temperature and humidity, now all of a sudden we can start having problems. At its most extreme, maybe we would get structural collapse. Our wood buildings are so immeasurably strong, I just don't ever hear of that happening. That would be like such an outlier, we don't even have to think too much about it. I think the bigger issue is probably more respiratory issues, indoor air quality issues when it comes to homeowners. It just seems like people are getting more and more sensitive to things, and we want to be able to not make them sick. Honestly, that's one of the primary reasons to have an unvented crawl space, is to try to make that area live more like the main part of the house. We just don't want people to get sick at the end of the day. Another thing that can happen is if we start having leaks in our supplies or our returns for the mechanical system, if we're going ducted, is we can start losing some efficiencies perhaps for the unit itself, or we're not going to be supplying or drawing the right air from the right places, or supplying to the right places. And I would say maybe most duct systems aren't tested properly to see if you're actually delivering the air that you're supposed to be delivering to the different places. If you had everything sealed up super tight, maybe everything is okay on that. Okay, another factor here, the way we typically do it, just bear with me for a second. In the past, we've done unvented crawl spaces where the insulation goes in that floor diaphragm. And then we've got our black plastic. We built this way for years. But everywhere where you have your vent, you now have this interface of air between what's in the crawl space and what's outside. Now, if you were 65 degrees at 50% relative humidity inside, and precisely the same air temperature and the same moisture content outside, there would be no gradient difference. You're not going to get any transfer. But if you're at 60 inside and you're -5 outside, you're now going to start getting some inefficiencies when it comes to your heating equipment. Conversely, I was just reading an article, and I think it was Las Vegas had a record of 4 of its hottest days ever in 1 week. So that was like 120 degrees over and over again. So imagine having 120 degrees outside, and you want to be living in this zone of 70 degrees plus or minus, whatever your comfort level is. You're going to have an inefficient situation there. So ultimately, it can come back to cost. So then the question is, how do we build this in the most cost-effective manner? That's something that we'll show you in a little bit. Another thing that happens with an unvented crawl space is you have a little bit more, it's more homogeneous between that space and up above. In other words, you're not going to be having these huge delta differences between the house and the crawl space. So you shouldn't get the seasonal variations in wood that you might if you leave that open to the outside. It's actually interesting in our area, even though we do get a lot of rain in the wintertime, we don't have much humidity, the moisture content in the air spaces where there aren't drops is actually not too high. It gets cold. Cold air typically is dry air. So we always build with true solid hardwood oak flooring. And in the wintertime, we get gaps depending on how we built, because it's shrinking because the absolute moisture content is reducing, so that volume is getting smaller. In the summertime, you can get it to where you start getting some cupping if you start adding moisture. So it's just, wood never dies even after you cut it down. If it starts collecting that moisture, it's now going to expand, and you get these seasonal variations. Maybe it's a problem for somebody, maybe it's not, but if we can keep all of that in a more, if we keep our highs not as high and our lows not as low, and we're able to shrink that and have that house kind of coast in that area, the numbers are probably still going to go up and down, but try to reduce those extremes. The materials themselves should lead to fewer callbacks. And if I could get a shirt made up, it would be, I hate callbacks. That's much of how I started working for Dad back in the day, is he would build the house and I would get the privilege of customer service. And thanks, Dad. But you learn a lot. You learn a lot. And if you can eliminate having drywall pops, if you can eliminate having gaps in your baseboard, your flooring, your cabinetry doesn't warp so much, that's a big win. If it's a super high-end climate and a client and you have sensitive violins, artwork, piano, that's kind of a whole nother mechanical solution that you would have to be contending with, plus the homeowner who might have an attorney on retainer. But if you put your crawl space in an unvented place, you've helped. So consider that part of the system, not just the solution. And I've gotten ahead of myself, but it is what it is. I guess I'll talk just a little bit more about the stable air temperature. I would say probably the cheapest insulation that we can be putting in our houses is fiberglass bats. And that's okay. That's not a criticism. We do it. It's totally fine. Remember, it's not the insulation itself that is making the wall energy efficient. It's to the extent that the air doesn't move. So if you can build your stud cavity airtight, you're going to be golden. It's going to get up to temperature, and it's going to be just fine. You don't have to use other solutions. But in a crawl space situation, if in your floor joists, in your joist bays, you're installing, the building code calls it permeable insulation. They can't say that it's pink fiberglass bats. Permeable meaning pervious to air, not impervious. When you're having these delta differences, especially where all of your vents are, that's where you're going to start getting that wind washing effect, which is going to reduce the efficiency or the effectiveness of your insulation. So if we can eliminate having windows in our crawl space, we've now increased the efficiency of our insulation. Technically, the way you're going to do your insulation isn't even in the floor joists, but if that's how we're doing it with a vented crawl space, that's going to be an issue. All right, let's check our time. We might actually have time for some Q&A. So we've talked about the building science or that we were going to talk about the building science recipe. You're going to see a series of videos that I did basically on Instagram, and it was nice because I was able to reutilize them for this. So I think I explain it well enough. I might elaborate just a little bit, but hopefully just the verbal here will let you guys know what we're dealing with. And we start with a clean slate on one of the foundations that we actually built. So in this case, instead of starting from a gravity perspective like we did at the beginning at the ridge, we're going to start at the ground. So there's different manufacturers out there. I'll give just the quick plug to ICS. They have a double-sided tack tape. In this case, they've got the release liner on one side. On the underside of the tape is also adhesive. So that's a material that you can use when it comes to your foundation, and you'll see an example of that in a second. So let's watch it. We are finally on site. We're going to show you step by step what it takes for the hidden crawl space that we're doing. Maybe unvented is a better term. So obviously we have the cast-in-place concrete. Now this is the tack tape from Sashco. It's a double-sided tape, one little tip, you'll figure it out quickly yourself. The first part of the tape that we take it off the roll, tack's really gut. Once you get past that, it's fine. So this is the end of it. As you pull the release liner, again the top has liner on it currently. This is going to get nice and tight. Roll the tape, and we're holding it to the inside. Once this top portion comes off, you'll see the next step of the actual Sashco crawl product that'll come up here. We're the mud sill is going to act as the termination bar. So that was always a question for me is, when it comes to the actual membrane, how do you attach it to the foundation? Typically, what we've done in the past is just run the 10 mil or 6 mil poly, not millimeter, just in case anybody doesn't know. Mil is a different definition of thickness. We would just run it up to the foundation wall, and that would be okay if we were just trying to mitigate for water vapor. That black plastic is not a waterproofer. I just can't emphasize that enough. But if the water vapor is coming up in a more of a uniform manner, and imagine if we had it through this whole auditorium here and we held it back just 1 foot from the walls, you're probably going to be okay because you're only having that little bit of linear footage that's exposed. The rest of it is all being controlled in the field. But when you're doing unvented the way we're doing it, we want to do it just a little bit differently. You can use a termination bar to affix it. I think somewhere in the code, I don't know if it's still there, it talked about a permanent attachment. Very vague term. I want to make crawl space work as easy as possible. In my opinion, anytime we put somebody, oh, and that reminded me of one other point, in a very difficult physical condition, a contorted condition, it's super hot, it's sweaty, you might get as good a job, but if it's easier to install, I think we can be more precise. So doing it at this stage is going to make your life a lot easier. Yeah, we'll keep going. So then on the structural side, earlier we showed the anchor bolts. Here's an alternative. This is a Simpson Titan anchor that is post-installed into your mud sill. So I think I talk about it here, so let's see. You might remember the last video I showed you the installation of the Sashco crawl membrane. By the way, it is a vapor retarder and a soil gas retarder. Anyway, so here's another unintended consequence of the change that we made a while ago. Instead of doing cast-in-place J-bolts, you might remember I commented on using Titan bolts. So here's how those actually get installed. Obviously, I'm just showing you kind of a cross-section view. The Titan will get embedded into the concrete. Of course, it'll thread through your mud sill, but then the plate helps to distribute the load. This is what helps hold down, we use the term hold down, your structure to the concrete. So, unintended consequence, just imagine if we had a bunch of J-bolts sticking up through here, and this was our detail for the building science side, there would essentially be a conflict with the structural side or the workers. Yes, it could be done, but anytime we get more technical, let's try to make it as simple as possible. So you might notice what we did there is we had strips that came in. Check your weather and have multiple avenues of execution available. If it's incredibly rainy and you put all of your vapor barrier down at this phase of construction, that's not going to go so well. You might just create yourself a swimming pool and then you have to get a sump, or, I mean, it's just, there's different methods. So we draped it over and then we came back in later and taped everything together. One other thing that's nice, this membrane here, so I'll just show this to you real quick. This one is, oh, I clicked it. I guess we're watching. If you need specialty fasteners, nail gun depot, this is what we're using. This is one that's been deployed all the way. We will not be using that right now. But basically, you take the gun, install it, or insert it, and then there you go. So that little bit into the concrete, these sections will keep rubbing down, and we'll be good to go. All in all, oh, that was falling for a second. All in all, definitely a learning curve, but nothing that's been too untoward, and before you know it, the whole thing's going to be done. Okay, I'll come right back to that. The white membrane is super nice. This is like applying building science to using science to build. It's going to reflect light better, so if you're running your plumbing, and that's another advantage of a floor space, of a crawl space system, is it's easier to modify, do renovations. If you have a water leak, it's easily accessible, as opposed to if you have an issue of something that's cast in concrete or in a basement, if you've got things that are run overhead in drywall, it's very easy and accessible. Having something that's light colored makes it a little bit easier because of the reflectivity of the material itself. So if you're on your back and you're wiring or you're plumbing or what have you, those open cavities are going to be easier. The way we have done it in the past is all of our MEP gets run, then the insulators come in, and you'll never be able to insulate around your 3-inch waistline properly. It's just not going to happen. When we can, I'm going to jump ahead now. When we can take that insulation and put it to the outside, you now have all of these wide open joist cavities to run all of your mechanical systems. It makes everybody's life easier, and then we've got the light as well. This is, again, 10 mil. Afterwards, you can come up and give it a stretch. We just installed this and this product. This has a metallicized facer on the back. Technically, it probably serves some radiant mitigation, but that's not its primary function. It has a little bit of, I think it's closed cell foam between it, kind of sandwiched. In any case, it's just to make it stiffer. It's more for a backer, and both of them installed pretty easily. One thing that we learned, just to pass on little tips, because it's thicker, the roll, even if the rolls are exactly the same size, there won't be as much material in each roll because one of them is thinner. But to have 10 mil is pretty nice, especially if you're going to do it early on in construction, because that 6 mil stuff is just going to get shredded. It just doesn't have the resilience. It's being specified just for vapor, not because it's a top-notch product. The Rockwool Comfort Board is different than a Comfort Bat. It's heavy, it's dense, and so we installed that on the wall, and that is a nice place to put it. You pretty much get all of your thermal bridging taken care of. One thing to consider, where your beams go and where your intermediate walls might be, consider working with your engineer to be able to hold those to the inside of the crawl space, and then use structural attachments over the top at the mud sill and your beams or your double top plate so that you can run your insulation behind it. If you're not thinking in terms of those sequencing, you're probably just going to frame the wall, or if you're just overseeing somebody, you're going to come up and go, oh, we missed a spot, and just move on. You're not going to rip it out for this much insulation. But if you can think ahead, I think you can do a better job. This next video isn't going to work, probably, but now we get to kind of the hat on the system. We talked about the floor diaphragm. We've used Huber Advantech X Factor. It doesn't allow vapor to migrate through it quite so much. It's not a vapor barrier. You can check with like your Hardwood Flooring Manufacturers Association or what have you. You might be able to eliminate putting paper underneath your hardwood because you're not going to be getting that vapor coming up through it. So that's what we use, and I'm going to hit click. It didn't work, so we'll move on to the next one. All right. So in theory, we have our mud sill sitting on top of our stem wall. We have this membrane that's under the mud sill. So that's going to keep all the radon, all the vapor away from everything. But technically, when you come on the outside with your exterior structural sheathing, there's going to be this strip that runs all the way around your building. And technically, now this is for the air sealing side of your house, you could get air infiltrating at the bottom. That's typically where it's going to be. And typically, you'll get exfiltration at the top of your building. So this is the last step on our building science recipe.
Critical location for air sealing. Clean the wall first.
3 inches.
See if that's true. No need for primer.
That just kills me. That's my brother, just so everybody knows. If you don't know him, Awesome Framers. I don't know where he got that voice. I've heard that more times than you will ever know in preparation for this. So you heard some of the benefits of it, and there are actually a couple of more steps. No primer, that's probably the most important part when it comes to air sealing if you're doing it from the outside. Because you're gonna have your neutral pressure plane somewhere in the house, that's where that air is gonna wanna infiltrate. So no primer is gonna be easier. Maybe there's another tape out there that you would like to use. There's other products. This is just so fast. And as a cost accountant, labor adds up in a hurry. On the mechanical side, this is a typical exhaust fan that we'll use in our bathrooms. This is the FV0510 VSCL1. Each of the parts of the nomenclature at the end refer to something. In this case, the C is condensation, L is light, V is probably ventilation. But in any case, it's relatively inexpensive. It uses an ECM, or electronically commutated motor, super energy efficient. We have to put this in to mitigate for radon, and I hope it never gets used. We would do a passive system. That's what we've done in this particular project. The way the passive system works, just to give an explanation on that, because I didn't earlier, soil in general is porous. So that's how the radon is going to come up into the house, is through those pores. Where was I going with that? Oh, I know what it was. To do a passive depressurization system, you'll have either kind of a drain tile, which means perforated tile under the vapor barrier, or your radon barrier in this case. And then it will look like a standpipe that runs all the way up through your roof system. The reason that works passively is the air near the top is going to get warmer naturally because of the way the house works. And it's going to get more buoyant. It's going to float. We can't see air, but we're just fish swimming in air, basically. That's going to naturally migrate up, and it will pull air from the soil coming up. So that's how that works. Even though we're walking on soil and we don't see it, unless there's some special geology. There's air in the soil, that's where the radon's coming from. If you are still getting high radon numbers, then you might have to add a fan to assist with that. The natural stack effect just might not be enough. So be aware of that. Consider pre-wiring, run a 120 volt or what have you up in the attic, and plan a place for it. If you're in a high radon area, or just do it. In the crawl space, this can be set basically to depressurize the system. Instead of having any cut-throughs the subfloor, I just don't want to have my crawl space air, even building it this way, interacting with up above. It's just me. I don't know if I'm right or wrong on that. And then as a belt and suspenders, use a Santa Fe dehumidifier. The only reason I'm doing the exhaust fan is because of the radon part of the code. Not because of the part of the code for moisture vapor. So we have this guy here, 70 pints, and we're going to install one of these at this particular project. Number one, I just love to learn things, but number two, let's just say that I did something wrong. Now I know what I'm going to be able to do with my moisture vapor. Energy efficient, super quiet. I don't know if you guys were able to make it to Matt's house. He has a Santa Fe up in his attic, and it was interesting hearing one of the other gentlemen comment on how quiet this piece of equipment was. I'm just going to say it. In comparison to his April Air that he has. So a little plug for you, Nikki. But that's the building science recipe. Hopefully you can take each one of those components and utilize them. Feel free to come up. And we have about 4 minutes for Q&A if you guys have any questions. Joel, please.
What was the main issue that you saw with your vented crawl spaces, and would you vent a crawl space again?
I don't have the data, I just know it's better.
What's better?
In unvented.
Unvented is better than the vented?
All things being equal, for all of the other reasons. I kind of use the Subway McDonald's analogy in some of these things. So sometimes when I'm doing my cost accounting or my budgeting or whatever, I get extremely granular. Like, to the penny, let's figure this stuff out. That kind of a mentality. Other times, I know that if I get a veggie 6-inch Subway, it is going to have way fewer calories than a double quarter pounder from McDonald's. So it's not a perfect answer, but there's some things that I do that I haven't run all of the numbers on. I just know this is going to be a better way to do it. And I partner with different companies to where I get to try it out. And then I learn what I didn't know before, and I can use that in presentations. Nikki?
Are you putting mechanicals in your crawl spaces?
The only mechanicals that we run sometimes now, we always have a VRF system. We'll run our refrigerant lines through the crawl space. So it does go through that interstitial space.
Because in a hot, humid climate, a lot of times mechanicals are down there. And when they're vented like that, and you go down there and see a HVAC system, and they're completely rusted and sweating, it does significantly reduce the lifespan of your HVAC equipment in a hot, humid climate. And they're definitely, you know, when you go to that southeast and dealing with moisture, some of the things, you know, you went all the way up your wall with the vapor barrier. You got to leave a 3-inch
Yes, thank you for
termite
mentioning
inspection
that.
gap and stuff. So it's interesting to see the differences in a heating-dominated climate versus a cooling-dominated climate and how that works.
And I don't know this, but I'm guessing Florida's not a radon area.
Not a lot of crawl spaces in Florida, to be honest with you.
Yeah.
Once you get to Georgia, but there's you can't predict where there's
Yeah.
radon, to be honest with you. You should always test before and after.
Yeah. But I'm glad you mentioned the bugs. All things being equal, you'll have fewer critters and termites and bugs and things. We don't have termites in our area. So definitely don't take everything I've said as what you should or shouldn't do. But, okay. Yes, please. Last question, I'm afraid.
Sorry, I noticed, I haven't seen the video when you put concrete at the bottom of the floor. Is it necessary for
So one thing that you can, he asked if you can put concrete on the floor of a crawl space?
Right.
Okay. I believe in the code it's 2 inches and you can get away with not having a vapor barrier. So it's commonly called a rat slab. So if that's a path that you want to do, you can do that instead, but double check me on that. That's something I'd like to do at some point just because it's a little bit easier on people to work off of, easier to clean. And clean your soil before you put the membrane down. Do it before you've got your floor joist system on. I was the cleanup guy, so give the cleanup guy a break.
Can I get that video? You got a copy of that video?
Which one? Well, just follow me on Pioneer. Oh, the code stuff?
I mean, no. Just follow you on where?
So the video should be on Build Show Live or buildshownetwork.com in the future. I have to wrap this up. I'm afraid I have a floor presentation to get to. But I just thank you guys. You're a nice audience, and I really, really appreciate it.
It's been a great week here at Build Show Live in Austin 2024. I want to thank one of our project underwriters, Polygaurd, who is providing this content from our classes, which were amazing in client management, building durability, and building science, where Polygaurd has been a leader in air and water management for a long time. We've used a lot of their below-grade water management solutions, but they brought out some great new stuff from their termite prevention to their air control products. Polygaurd's been solving things for builders for a really long time, and we're grateful that they're still working to make our lives easier every day. Thank you to Polygaurd, and thank you for your continued support of our educational content.